Okay? Yeah. I sort of coupled to that acoustics, and now it's different. So, new, fresh start at this moment. Well, basically, fluid is like your mind, and molecules are like your neurons. And no single molecule has any fluidity, no temperature, no color, no pressure. And when you've got really many, like more than 10 to the power of 20 molecules, you get the macroscopic system that exhibits these emergent properties. It means that systems that have got far less elements than 10 to the power of 20, like a couple of molecules in a mesh or something, most of the there is no thermodynamic error of time, for example. So most of what is done can be easily undone. But most of you can realize that a fried egg cannot be unfried in the macroscopic world. How is it possible? How is that it cannot be unfried when all of its elements can be, undone what has been done to them? Well, emergent systems in cognitive science or emergent systems in cognition, to put it very briefly, let's say that mental states, which means something in your mind, let's put it into something that I will call mental causal domain. Causal because your mental states, mental processes, cognitive processes, they've got some causal potential. They cause something. If you see something, perceive something, it can cause you to be afraid. It's got causal potential. And neurons, let's put it into the neural causal domain. It means that if one neuron is firing, then it will do something electromagnetical or electrochemical to the neighboring neuron. It's got nothing to do with your thoughts, with your mind. It's in a very different neuron, but it's somehow interconnected. These domains are disjoint, but in mutual influence. And what is the nature of this influence? Is this influence causal? Does the phenomena or processes in one domain cause, really in terms of causality as it is understood in science? Do they cause phenomena in the mental domain? I'll show that they probably do not. It's contradictory to call it causation. Let's say in terms of Karl Popper's understanding of what causality is, which means something arbitrary given, something like a fishnet given over the world with a theory describing that part of the world. Basically, what's the problem with the contemporary science, which I will call classical science? It forces you to the mode of thinking that is compatible with classical induction, which means one neuron doesn't cause consciousness. N+1 neurons don't cause consciousness neither, which means that consciousness doesn't exist, that these are just epiphenomena. Reductionism is the solution to this. It simply says that your mind is nothing but your brain. It's simply your brain, and that's not true, right? We are conscious. At least I am conscious. I don't know how about you, but I'm forming my own science here, and so yeah. Classical science. I've already mentioned this classical induction. It means that if you can, let's say mathematics, if number one, if for number one holds the attribute A, and you can prove that attribute A is for every n+1, then it means that attribute A holds for everything. And this is what I already said. One neuron doesn't cause consciousness, 2 neurons, 3 neurons, 4 neurons. So where the consciousness comes from, where the mental states come from. The problem with classical induction is actual infinity. Actual in terms of the fact that the actual infinity is understood as being all at once. It's not a line. Actual infinity is what a Christian omnipotent God sees in his mind. It means everything atemporally, everything at once. I think even old Greeks didn't have actual infinity. They had potential infinity. Zeus, when he wanted to draw a line, he could always make the line longer. But he just had to perform that act. And Christian God was better than all the pagan gods because he had everything at once prepared. This is the problem. This is the heritage of the Cartesian Newtonian understanding of the world, where you, from the very definition, I mean, Descartes wanted it to be like this. He sort of excluded subjectivity from the realm of science. Subjectivity is attribute of res cogitans. It doesn't have to, I mean, science is not going to talk about res cogitans. And the rest of it is res extensa, which is without any unsharpness, as I will mention later. So no wonder that a couple of centuries after this, our science simply does not possess any tools for description of our, any non-reductive tools for description of our minds. If we want to do anything with the mind, we simply need to follow the road of reductionism. Moreover, emergence is simply formally problematic in mathematics. So what to do with it? The whole contemporary mathematics is simply classical set theory. It wasn't before the 19th century. There were many branches of mathematics, and intuitively mathematicians usually don't work in set theory. But every mathematical framework in these days has got its model in Cantor's classical set theory. The classical set theory postulates that infinity, whatever infinite set, is bigger than any finite set. Simply infinity means inherently being bigger than anything finite. As I will show later, this is simply a habit or something, because infinite means that it doesn't have its last element, not that it must be bigger than anything finite. Everything in the classical set theory is crystal clear. It means that there is no room for unsharpness, no room for vagueness. I mean, fuzzy set theory, most probably you've come across it. It's fake. It's simply, there's no unsharpness in it. It can be very easily reduced again to the classical set theory. So don't believe the people who say that a fuzzy set theory introduce any vagueness or unsharpness into the set theory. It's just some module plugged into the classical set theory. And it can be reduced to the set theory. Now imagine you're an analytical philosopher and you use your classical set theory for description of the language, and you want to describe, for example, the notion of red, what it is to be red. It's a set of the red things, let's say, and what it is to be non-red is the complement of that set, which means the whole minus what is red. And according to the classical set theory, the complement of the set is qualitatively exactly the same to the original set, which means that you come to the conclusion that by knowing non-red, you simply can infer what the redness is, which is not true for the natural world. This is not. I mean, if you haven't seen anything red, just non-red things, you've got no phenomenological idea of how to construct redness or red, the concept of red. Now, what is the solution that I would like to offer? Despite the picture that looks like something, a path to a bright future or something, I just wanted to illustrate the basic concept of path to the horizon. This alternative set theory is a alternative to the classical set theory developed since 1960s by a quite renowned Czech mathematician Petr Vopienka, whose made his success in 1950s in the classical set theory. He came up with the so-called Vopienka's principle, blah, blah, blah. Then he realized how bad classical set theory is when he was one of the best mathematicians around the world in it. And he introduced the concept of natural infinity. It's the infinity that we as phenomenological beings are exposed to. Natural infinity is something that you see on the path to the horizon. This is very, now I have to explain in a very intuitive way. I mean, it's got really formal mathematical foundation, which is impossible to even show you on this screen here. So basically the most intuitive explanation of this is if you imagine the path to the horizon, like this one. You can see the stones, and now let's say you want to count from the viewpoint of the observer. It's one important moment. It introduces the observer into the mathematics. This is, I mean, has not been probably in mathematics before. And it means that on the path to the horizon, there is no last step that shall take you to the exact place where the horizon ends. It's like chasing the rainbow. You can do always one more step, but you still don't reach the rainbow. And if you close your eyes and do kind of a leap of faith, you immediately realize that you've already passed through the rainbow. It's behind you. It's the same thing here. If you want to count the stones that go, or I mean, step by step going to the horizon, you will not be able to say that this step is the last step leading you to the horizon, and step plus one will be beyond the horizon. This is exactly how phenomenologically the world works, and this is how exactly the classical mathematics doesn't or is not able to grasp it. So alternative set theory, basically, natural infinity is basically unsharpness or vagueness, which has been exorcised by Descartes. Mathematically, Vopienka introduced something called horizon segment. Segment is an ordering of natural numbers, like 1, 2, 3, 4, 5 is segment, 1, 2, 3, 4, 5, 10 is segment, 1, 2, 3, 4, blah, 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 10 billion is a segment, but the problem is with this blah, 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 blah. Classical set theory says that blah, blah, blah doesn't matter, but alternative set theory says that this is exactly what matters, this blah, 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 that you're not simply able to reach to that point. So horizon segment on natural numbers is portion of natural numbers that has no last element in natural number numbering. You cannot say that 1 billion, 3 million, blah, 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 is the last element. You simply construct such a mathematical entity that in this ordering has no last element, but has a solid, finite extension of that. You cannot do this with small natural numbers. You cannot do this with what you can grasp in front of the horizon. It's simply, you postulate that your mathematical framework works like this, that it's got entities like this. These entities are called semi-sets. Semi-set is a sharply delimited subset of huge, very large, finite sets. Well, I'm running out of time, I know that. But after a long chain of lemmas, theorems, proofs, etc., etc., there are two basic kind of semi-sets. One kind is called sigma semi-set or sigma class. The other one is pi class. Sigma class simply means that you can, let's say, easily construct it. Sigma classes are abstract structures that stand for things like concepts. So if you want to represent it, so sigma class, I mean, if you compare it with this, you've got the set, and here you've got the classes which look like kind of fuzzy cloud, and it's very crystal clear in the center in its kernel, but it somehow diminishes to the horizon of it, and you never can say that this element is the last one of that sigma class. And there are pi classes, which are simply kind of black holes. And it can be shown that the complement of a sigma class to its super class is pi class, which means that the complement of red, it doesn't work like this. I mean, now here you can say that the negation of being red is non-red. This is perfectly okay. So from knowing sigma class of what it is to be red, you can infer what it is to be non-red. But it doesn't work the other way around. You cannot get from the pi class to this sigma class. So simply by knowing the non-red things, you can never get to know what it is to be red. So this is just a brief example of how alternative set theory can be used, let's say, in analytical philosophy. But here, something about the horizon. I don't know how much I'm running out of time. But never mind, everyone has been running out of time. So again, these horizons, where we can find them. Most of you probably know classical Sorites paradoxes. It means how many grains of sand you have to take away from a pile of sand so that it stops to be a pile, or how many hairs you have to lose to be bald. Yeah, it works. I mean, every morning I check it. And it's simply, I mean, most of us can, I mean, most of males here can, I mean, say something on this topic of alternative set theory. And if we were in the realm of classical set theory, we would never lose our hair. I mean, by losing one single hair, you don't, you know, it's perfectly okay, but I can see it. If I look at 10-year-old pictures of me, then it's proof. Another example, I mean, I often ask my students how many, well, if the number of the sand grains in Sahara Desert is finite or infinite according to them. Most of them simply from the habit say that it must be finite because yes, it must be, well, but how is it, well, how do they know? The only way how to count something is to take them one by one and assign them with natural numbers. The only way how the contemporary science is able to, well, says that it's the finite number of sand grains is that they do this for a very limited, I don't know, for a bucket of sand or something, and they count to 10,055, and then they use the apparatus, the framework, mathematical framework that has been designed to provide you only with finite answers, only with finite results. But they have forgotten this. So they multiply how many buckets of sand are in the Sahara Desert, and then they say, voila, we've got finite number of grain sands. I'm not saying that it is actually infinite as in actual Christian God infinity. I'm saying that the number of grain sands in Sahara Desert is naturally infinite. I've already mentioned the extension of being red. Hagel's donkey, a classical example. You know that if you've got a donkey bearing something and you add 1 more gram to the donkey, it makes no difference. But still you know that no donkey on the world can carry 1 million kilograms. So you've got the solid extension of that. You never can say what is the last 1 gram addition to the donkey, but still you know that it's less than 1 billion. The way from Charlie the chimp to the Charles Darwin. You know, let's say, okay, this is nothing to do with the evolutionary Darwinism, but let's say we really are from the descendants from the monkeys. So no monkey can have a human child. So how many, and let's say that Charles Darwin as a human is descendant from some really ancient monkey. So how many monkeys from Charlie the chimp 10 million, I don't know, 100, I don't know how many million years ago, how many monkeys were before the monkeys transformed into the human? It's a sigma set, a sigma class, or horizon segment, or phase transitions, it means the time moments till death. I mean, if you are in one discrete time moment alive, then you must simply be alive in the very closest time moment, because there is no intermediate time moment that would change you from life to death. The same the other way around. You've got, after conception of human being, you've got two cells, and they start to multiply. One cell is not a human being. One cell or most women, dispose those cells every month. So 2 cells, it's not a human being. 3 cells, 4 cells, it's not a human being. So how many cell multiplication it takes to become a being? It's again a sigma class. Okay, and I'm reaching the end. It's the same with neural nets. Well, I've got still many things there, but I think I should already, finish my discussion here. Well, okay, basically, so if you, I've got just 2 more slides. If you imagine the body-mind problem stated in terms of neural causal domain and mental causal domain, and you try to get some help from the classical set theory, you can create a, let's say, set theoretical model of one causal domain, one set theoretical model of mental domain. They've got kind of internal causation. You can, this is what science does. Neuroscience does the thing that it tries to uncover the causal relations within the causal domain. Objective psychology does the same for the mental domain. So this is intra-domain causation. But now we are interested in the inter-domain causation. So what phenomena from the neural domain can cause some phenomena from the mental domain? The problem is that it doesn't work. Well, in the classical set theory, you get to the contradiction that you simply get no mental phenomena. You've got just neurons, and the neurons through the classical induction will cover. There's no space for mental phenomena, but you feel on yourself the mental phenomena. You really want to know how they are related to the neural phenomena. Is it a causality or what it is? So you create 2 sigma classes instead of 2 classical sets, with all their specific behavior that I'm not able to describe here. And you realize that it is contradictory to think of their mutual, to think of the inter-domain relations as causality. It is simply contradictory. If you're interested, I can send you a paper on this. Simply you got a logical contradiction, which means, this is the furthest result that I have so far achieved, it means that you cannot say that there is causal relations in terms of Karl Popper, for example, causal relation between neural causal domain and mental causal domain. There is some relation, but not causal relation. Might be, for example, teleological relation, which means that neurons reforms themselves so as to fulfill what your mind does, actually, or something like this. I'm not saying that this must be like this. I'm just trying to offer some alternative to this, but it's not the physical like causality. And that's it. Thank you.